Good morning, and once again welcome to my YouTube channel, Pearson and Excel International A-Level Maths by Mr. Kamotho. And today we shall be discussing the very last example of topic number 6, differentiation. And we're looking at example 20, page 140. And that example is quite important, so I want us to follow closely. And we are told that given that y is equals to arctan 1 minus x over 1 plus x, find dy dx. And of course we need to find the differential of this function, find the dy dx. And if you look at the expression, given that y is equals to arctan, this expression, you realize that arctan it's not a single variable. And if it is not a single variable, we cannot just differentiate directly. We need to introduce some other representative. For example, we need to talk of this one being equals to a certain letter U, Y, Z, or anything else. So we know that the rule that you are going to use here, we know that if we have learned this from the previous video, if y is equals to arctan x, then dy dx is going to be 1 over 1 plus x squared. That is very important piece of information for this example, very critical. So put in mind that even as we move forward. So therefore, this is going to be represented by another variable. So we say let u be equals to 1 minus x all over 1 plus x. And at that particular point, you will realize that if u is equals to this, then it is a fraction. And of course, a fraction, we'll have to use what we call the quotient rule. And we say that du dx is going to be the denominator, which is v. Let's just write the denominator, which is v, which is 1 plus x, times the derivative of the numerator, which we are going to talk of u, which is negative 1, minus the numerator, which is 1 minus x, multiplied by the derivative of the denominator, which is just 1. All this is over the denominator 1 plus x squared. If you open this bracket, we are going to talk of opening this bracket, we are going to say that du dx is going to be minus 1 minus x, and then minus 1 plus x minus 1, negative 1, negative times negative becomes plus, plus x, everything multiplied by 1, then that is just like it is all over 1 plus x squared. So if you clean up the numerator a little bit, you're talking about minus x plus x will cancel out, and you're going to have minus 2 all over 1 plus x squared. That is du dx for you. But of course, the moment we brought y is equals arctan x, we said that the moment we made this u, then we are going to have y is equals to arc tan u, because this is u. And of course, if we work with this according to this approach, we're going to find that dy du is going to be, according to this, 1 over 1 plus u squared. And at that point, we can say, or rather we can talk about the chain rule, because dy dx is what we are looking for, is going to be given by dy du times du dx. Luckily, we have both of them. And dy du is simply 1 over 1 plus u squared multiplied by du dx, which is this du dx, which is minus 2 all over 1 plus x squared. Fine. We now have to substitute for u, because u was not originally u. U was 1 minus x over 1 plus x. And at that point, we need to talk of it like this is going to be equals to 1 times minus 2 is going to be minus 2 all over 1 plus u, 1 plus u squared, and it was what is now our u, 1 minus x, 1 minus x, 1 plus x squared multiplied by 1 plus x squared. So we have to take great care of this denominator, because at the end of the day, we are going to say that it's going to be minus 2 all over 1 plus, we may expand this for the sake of clarity. We may expand this for the sake of clarity. And it's going to be 1 minus x over 1 plus x multiplied by 1 minus x over 1 plus x. All this now multiplied by 1 plus x, 1 plus x. And it goes without saying that if this is 1 plus x squared, opening the bracket at the denominator, we have minus 2 all over 1 times this, because 1 plus x squared affect each and every time in this bracket. We have 1 plus x squared, we have 1 plus x squared, then this part multiplied by 1 plus x squared, of course it cancel out, that goes with that, that goes with that. So we are having plus 1 minus x squared. When we expand this, we are going to have minus 2 all over, this is 1 plus x squared, which is 1 plus 2x plus 2x plus x squared. We have expanded that, plus we may open another bracket here. 1 squared is 1 minus 2x plus x squared. So if you open this bracket now, we are going to have something that looks like minus 2 all over 1 plus x, 1 plus 2x plus x squared plus 1 minus 2x plus 2 plus x squared rather, plus x squared. Plus 2x minus 2x cancel out, and finally we're going to have minus 2 all over 1 plus 1 is 2 plus 2x squared minus 2 plus 2x squared. And at this point, we can say that we have got differential. All we have now is to clean it up, and we're going to have our dy dx to be equals to 2 minus 1 all over 2 1 plus x squared. So at that point, that 2 and that 2 will cancel out and be left with minus 1 all over 1 plus x squared. That is it. And you realize that this is quite an important expression. It's quite an important expression. So we have just, to get to this step, we have just cancelled out or divided both the numerator and the denominator by 2 to get to this particular step. And therefore, that is just like it. It is quite an important question, but of most importance, we started by renaming this part because it is not very primary. It has undergone some processes. We have to name it to look like a primary variable, and of course we employed this knowledge which is general. And moving forward, you cannot forget that we have already used the chain rule, which is coming in handy in assisting us. Yet it is a question that you ought to be very careful because it can be very confusing. But anyway, that is it. And once again, visit to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and subscribe, share widely, and of course like. Yes, that's the end of the topic number 6, differentiations. We are on the lookout for the next topic number 7, integration. Thank you, and once again welcome.